Hello and welcome to the third and final paper from the November 2019 Edexcel series Higher Tier Maths exams. So we're going to talk through all of the questions. Some questions give you more than one method, and even if I don't mention a method you've used, it's not to say your method is not completely acceptable. If you're not sure, either ask your teacher, ask me, or leave a comment. So without talking anymore, let's have a look straight away at question 1 and get started. Question 1, expand and simplify. Fairly standard. We've got a x plus 5 and x minus 9. You can use FOIL, different methods. My preferred method is this one, the box method I call it, where we write one bracket along the top, the other bracket down the side. It doesn't matter which you write along the top, which you write down the side. You should generate the same answer either way around as long as you're careful. So what we do is multiply what's above the box by what's to the side. So first of all, in this box, x times x, we're going to get x squared. This box, 5 multiplied by x is 5x. This bottom box, x multiplied by minus 9 is minus 9x. And finally, 5 times 9 would have been 45, so 5 multiplied by minus 9 is minus 45. You then need to simplify all this together. So we have 1x squared term. 5x take away 9x. If you're not sure, just use your calculator. You've got a calculator exam, so you may as well use it. 5x take away 9x is minus 4. So you have minus 4x's, and then of course minus 45. And that's our fully simplified answer. Part B, it says to factorise fully. Now to say factorise fully, this is actually a hint. A common mark to lose here is just to factorise partially. What you need to spot is the numbers here, 9 and 6, there's a smaller number that fits into both 9 and 6, which is 3, and there's also a letter in each grouping, there's an x in each thing. So what number here fits into 9 and 6? And you want the biggest number possible. So 9 and 6 are both in the 3 times table. So they're both in the 3 times table, so you put the 3 out. And then there's x times x here, and just 1x there, so there's at least 1x in each. So we can factorise out both a 3 and one of the x's. There's nothing else common to each. Once you've got everything that's common to each, you then open the brackets and complete the job. So I've got 3x. The first thing I want is 9x squared. To go from 3 up to 9, I need to multiply this 3 by another 3. I've got x, I want x squared. To get x squared, I need to multiply this x by an extra x, so I need 3x. Plus sign, so stick a plus sign in. Now the final thing I want is 6x. So far on the outside I only have 3x's. How can I go from 3x's up to 6x? I need to double it, so I multiply by 2. And that, of course, is our final answer. So that's question 1 done. We're off the mark. Let's have a look at the next one. Question 2, use your calculator to work out this horrible calculation. Write down all your figures on your calculator display. There's not really, and I don't mean to be harsh or lacking in sympathy, but there's not really much excuse for getting this one wrong, as long as you use your calculator and know how to use it well. So this should be easy marks. I'll talk you through it. I would always recommend a Casio. I am biased. I apologise. So you just type it in exactly how it looks. So here you can see there's a fraction line, so tap the fraction button and just type in exactly how it appears. So 29 squared, 29 squared, minus 4.6. Toggle down to move down, square root, so type the square root button. Then all of these numbers are within the square root symbol. So then it's 35 minus 1.9 to the power 3, press equals. And this is our answer. You need to write down all the figures. So we've got 157.66. Can't remember the other numbers yet. 8255. Now part B is based on part A. It says to write your answer to part A correct to 4 significant figures. That means I need to keep 4 numbers counting from the first non-zero number. So starting from the 1, that's the first significant figure, second, third. The fourth significant figure is this 6. 1, 2, 3, 4. So the answer might be 157.6, you might think. However, next to this 6 is another 6. If the number next to your deciding digit is 5 or more, you round it up. So this 6 actually gets bumped up to a 7 because next to it, this 6 forces it to round up 1. So we've got 157.7. I'll very quickly show you how you can get your calculator to round to significant figures for you. So what we do here, to get the calculator to sort of do the legwork for you, I'm not really recommending this, but it's quite a cool thing to know how to do just in case. You can press Shift menu, and then go to number format. Press option 3. So fix is if you want to fix it to a certain number of decimal places. If you're wanting to go for a certain number of significant figures, it's SCI for scientific mode. So press number 2, then press how many significant figures you want your answer to be to. So I want it to be to 4 significant figures, so press 4, then press equals again, and then you see it gives you 1.577. You sadly need to work out this bit at the end because it gives it to you in standard form, but it does essentially let you know that your answer needs to be 1577, as long as you can work out where to put the decimal point yourself. So 1577, as you can see, that's what we've got here, 1577. Then we adjust the decimal place accordingly. To get your calculator back into the normal mode, Shift menu again, 3 for number format, 3 for norm, not hard to guess that means normal mode, and then for some reason option 2 is best, so press option 2, and then you're back to where you started, no harm done. Your calculator then is back to normal. Question 3, we have a scatter graph. I'm not even going to talk through anything else. I'm just going to focus on the fact it's a scatter graph. Whenever you see a scatter graph, always be thinking it's going to relate at some point to a line of best fit. Almost always. I can't recall the last scatter graph question I saw where you don't need to do a line of best fit. So, scatter graph implies do a line of best fit. A line of best fit needs to go and follow the trend of the points. So these points look to be going up like this. So the line of best fit will be going through these points. And as a general rule of thumb, you need roughly the same number of points above your line of best fit as you do below it. And if a point is way off, it's called an outlier. Don't try to force the line of best fit to go for a point which is way out. But all of these points seem to more or less be on the same line in this direction. So my line of best fit, I went for something like this. Now we can use this line of best fit to answer the question. Jamie got a mark of 34 in the science test. So Jamie scored here. So what we can do now is do a vertical line up until we hit the line of best fit, and then along, and we can read off the corresponding maths test mark, which is our estimate for what he would have got in the maths test. So get your rulers out. You should see it's something a little bit like this. Up and along. I personally get 39 marks, so my estimate is 39 marks on his maths test. It always depends on how you draw your line of best fit, and it is an estimate. So if you're sat there at home thinking, well, I got 36 or I got 40, it's not to say you're wrong, as long as you've got a line of best fit to show you're working. What you do need is an answer in between 30 and 40. Otherwise, if you've got something different to 30 and 40, your line of best fit isn't quite close enough. Question 4. A table giving information about the times taken in seconds by 18 students to run a race. We need to estimate the mean time. So it's a grouped frequency table. We need to estimate the mean time. This is where you need to know to take the midpoints of these intervals. All this group tells us is one person ran somewhere in between 5 and 10 seconds. What's your best estimate? If I were to tell you someone took between 5 seconds and 10 seconds to do something, you'd go for the midpoint, 7.5. So we need to add on 2 extra rows, 1 for the midpoint, and then afterwards we're going to multiply those midpoints by the frequencies. So the final column after midpoint is midpoint multiplied by frequency, something that looks like this. That's what you should ideally create for yourself. So these midpoints, this one's going to be 7.5, 12.5, 17.5, and 22.5. If you're not sure how to work them out, add your lower number and higher number together and then half them. So your midpoints for your 18 students, by the way, so total of all the frequencies is 18. Now the midpoints live here, like I just discussed, and then we multiply these frequencies by the midpoints and put the values in here. So we're going to do 1 multiplied by 7.5, 2 multiplied by 12.5, and so on, and record the values here, like so. We next total up all of these midpoint times frequencies and put the value here. So 7.5 plus 25 plus 122.5 plus 180, that gives us 335. So 18 is the total students, 335 is the total time approximately, it's not exactly, because we've estimated it by using these midpoints. The final step now to work out the mean is to take the total of the times and divide by the total of students. So our estimate of the mean is going to be 335 divided by 18, which to 3 significant figures should give you 18.6 seconds. There is an easier way to do this on a calculator, but don't just rely on your calculator to do it for you. You need to show the examiner you know how to do it using your own method. But a quick calculator check I'm going to show you now. So we press menu, and then we can scroll along to something called table. Press option 3. Oops, my bad. I'm not remembering very well here. So what we need to do here is we press 2 for statistics, and then it's one variable. The only variable we're talking about is times, so press 1. And we need a frequency column here. So to get a frequency column, press Shift menu. Then we're going to scroll down to statistics, press 1, and turn frequency on. Now, instead of the actual boundaries, we just type in the midpoints. So 7.5, 12.5, 17.5, 22.5. And then the corresponding frequencies, if we toggle along, we had 1, 2, 7, and 8. So 1, 2, 7, 8. Press equals, then press OPTN. Now what we're wanting here is option 3, one variable calculation. So press number 3, and then the mean is given by x with a little bar on its head. So x bar is 18.61 recurring, which to 3 significant figures is the 18.6 we got. That's how you can use it on a calculator. That said, you might be sat at home thinking, well, it's probably just easier doing the table. That calculator method is a bit of a faff. So it's your choice which method you want to use, either with the table like so, or you can use the calculator function, which is the statistics mode. It takes a bit of practice, but it's worth knowing just in case. Question 5, we need to convert from cubic centimetres to cubic millimetres. But before we get ahead of ourselves, we need to know how many normal millimetres go into a normal centimetre, let alone the cubic thing. So how many millimetres make a centimetre? We just simply need to know that 10 millimetres make 1 centimetre. 1 centimetre is 10 millimetres. So how would you convert from just centimetres to just millimetres? How would you go from 1 to 10? Well, obviously, it's just a case of multiplying by 10. We can now build up and think about how you change from cubic centimetres to cubic millimetres. Well, the clue here is in the cubic. So power 3, if you cube something, rather than timesing by 10, what we'd have to do now is to times by 10 in every direction. So if you're cubing something, cm cubed, you're talking about a volume, a length, a width, and a height. So you need to multiply 10 in one direction, times by 10 for the width, times by 10 for the height. You need to multiply by 10 cubed. And of course, 10 cubed is 1,000. So each cubic centimetre is 1,000 cubic millimetres. So all we need to do is to times by 1,000, so 37 multiplied by 1,000 is 37,000 cubic millimetres. Now, another way I like to picture it is to actually draw out a diagram of the 3D shape that has the original volume. So imagine a cuboid, for example, with a volume of 37 cubic centimetres. So here's the simplest one I could think of. So 1 by 1 by 37. This imaginary cuboid has a volume of 37 cubic centimetres. What you can imagine now is changing each dimension step by step into millimetres. So 1 centimetre becomes 10 millimetres, that becomes 10 millimetres, and 37 times 10 becomes 370 millimetres. Then working out the volume of this one, of course it'd just be length times width times height. So 370 times 10 times 10, which should give us 37,000 cubic millimetres. A different visual method rather than just doing it this way. Either way, which makes more sense to you, go with that option. Question 6. I'm not sure if it's Nima or Naima. Anyway, he was driving to a hotel. He looked at his sat-nav at 13:30. That's 1:30 to you and me. 1:30 in the afternoon. So at 1:30, he's still got another 65 miles to go. We need to work out his average speed. So we're talking about speeds, times and distances. Speed equals distance over time, which we can use a magic triangle for like this. Speed equals distance divided by time. So let's piece all this together. We're told the distance he still needs to go is 65, so we know the distance. And the time taken to cover that distance from 1:30 is when he has 65 miles to go, but he arrives at 2:48. So how much time did it take him? Well, the time it took him is between 1:30 and 14:48. So that relates to the time. But how do you actually work this out in terms of hours? Or should we do it in terms of minutes? Well, the choice is yours. So for the first method, we can work in minutes, then change to miles per hour after. Or we can go straight for working in hours. So I'm going to show you two different methods. So working in minutes, so from 1:30, 13:30, then you could go to 2 o'clock, and from 2 o'clock to 14:48. What's the total time elapsed? Well, from 1:30 to 2 o'clock, that's 30 minutes. Then from 2 to 2:48 is an extra 48 minutes. And so this here, 30 plus 48, in terms of minutes, it's simply 78 minutes in total. So using the formula for average speed, so speed is distance, 65, divided by time, which is 78 minutes. So because our distance is in miles, our unit of time is in minutes, this is going to come out in terms of miles per minute. So don't think this is your final answer. It's not, because our final answer needs to be in miles per hour. So if we work out what this is, 65 divided by 78, we get 5/6. So I'll just leave it as a fraction. 5/6 of a mile per minute. But of course, if it's miles per hour, an hour is 60 times as long as 1 minute. And so if you've got 60 times the amount of time, you can cover 60 times the distance. So to change from miles per minute to miles per hour, all we need to do here is to multiply by 60. And that'll change from minutes to per hour. So 5/6 multiplied by 60 gives us 50. So this is an average speed of 50 miles per hour. Or you could have done it directly in terms of hours to begin with. So keeping it in terms of hours, from 1:30 to 1:48, another way you could think of that would be, that's 1 hour, because an hour after 1:30 would be 2:30, then from 2:30 to 2:48 is an extra 18 minutes. So 1 hour, 18 minutes, that's the same as 1, and how many minutes make an hour? It's 60, so it's 1 hour plus 18 sixtieths of another hour. So doing it directly, the method being in terms of hours, speed is distance, which of course is 65, divided by time, which we're going to work in hours. So keep it as a fraction. I'll show you how to do this on a calculator. So, press the fraction button, 65. Then the denominator, because it's a mixed number, there's actually a mixed number button on the calculator you might not be aware of. If we press Shift and then the fraction button, you can input mixed numbers. So we can have 1, 18 over 60, and press equals. And again, you still get 50 miles per hour. Finally, as a little bonus, I'm going to show you can do this on a calculator using just one direct calculation. So using this formula for speed equals distance over time, I'm going to remind you of a time function on your calculator. So we type the fraction button, distance is 65, and the time taken is a difference in between 2:48 and 1/2. And the calculator can work out time differences in terms of minutes and hours directly for you. So the change in time is 14:48 take away 1/2. So using the time function, these buttons here, 14 punctuate for hours, 48 punctuate for minutes. No seconds are mentioned, so we don't need to mention seconds. Then minus 13 hours, 30 minutes. And what do you know? Comes out in just one go straight away. So this button here is absolutely awesome. Takes practice to master, but there's so much you can do on a calculator. It is worth investigating. Not that you need to use your calculator for this question in this way. You could have just done method A or method B, but this here is worth knowing as well, because I think it's pretty awesome anyway. Knowledge is power, people. Question 7. Write down this number 32,460,000 in standard form. So, in standard form, we need the first part of the number to be in between 1 and 10. I'm pretty sure this number, 32 million, is bigger than 10, so we need to put the decimal place in somewhere else. So where could I put the decimal here to make it somewhere in between 1 and 10? Quite obviously, I'm hoping you agree with me, it has to go in between the 3 and the 2. So in standard form, we'd have 3.246, and those trailing zeros are not actually required. We then need to multiply this by a power of 10 to go from 3.2 to what it actually is, which is 32 million. So, the way we do this is to think about where the decimal needs to be here compared to where the decimal actually is in a whole number, which of course is at the very end. How many digits are in between? So, in between, we've got 1, 2, 3, 4, 5, 6, 7. So our power of 10 is therefore 7. If that's too much like hard work, how can you do this on a calculator? Well, I'll show you. Type in the number exactly as it looks. 32,460,000. Press equals. Now I go to Shift, menu, number format, number 3. Standard form is a scientific mode, so press 2 for SCI. And then here, just type in how many significant figures you require. If in doubt, just go for the maximum possible. But hopefully you can see here there's 1, 2, 3, 4 significant figures before any trailing zeros. So we can go for 4 significant figures, 1, 2, 3, 4. Press equals again, and it gives you the answer exactly. So I'd suggest not to be overly reliant on your calculator. This is just to show you it can be done. To go back to normal mode, Shift, menu, number format, number 3. Press number 3 for normal mode, and for some reason option 2 is best. This next one's even easier. Without using a calculator, if you times in by 10 and the power of 10 is negative, you just move the decimal place back. So move the decimal place to the left 3, because its powers are 3. So it goes 1, 2, 3. And what you'd have there would be 0.00496. A good pattern to spot is, if a number is given to you in standard form and the power of 10 is negative. The number or value after the minus, in this case for 3, tells you how many leading zeros you have before the first non-zero number kicks in. So in other words, there should be 3 zeros before the first non-zero number, which is a 4, 1, 2, 3. I'd suggest, though, to do this on a calculator, so just type it in exactly as it looks. 4.96 times 10 to the power minus 3, and press S arrow D, 0.00496. Finally, for question 7, part C, Asma was asked to compare the following two numbers. So she's got A, which is 6.212 times 10 to the 8, and B, which is 4.73 multiplied by 10 to the 9. She says 6.212 is bigger than 4.73. Fair enough. But then she says, so A is bigger than B. Is she correct? Give a reason. Well, sure, 6.212 is bigger than 4.73. But if you look at B, B's 4.73 is being multiplied by 10 to the 9, whereas A, the power of 10, is only 10 to the power of 8. So even though 6.212 is a bit bigger than 4.73, this here is 10 times bigger than 10 to the 8 because it's got an extra power of 10 on it. So ultimately she's not right, but keep it simple, stupid, in your explanation. Something like this is all you need to say. Ultimately, is she correct? No, she's incorrect, because the power of 10 in B is bigger than the power of 10 in A. And that'll do you absolutely fine. Question 8. We have a diagram with a regular pentagon and a parallelogram inside it. And to work out the size of this angle here marked X, I need to show all of you working. So the key thing here is a pentagon's regular. So we need to know certain facts of regular polygons. So for a regular polygon, it's actually very simple to work out each exterior angle. So the exterior angle, I'm going to just label on here. Because a pentagon's got 5 corners, there's going to be 5 exterior angles around these corners, like so. So each of these are exterior angles. The interior angle, by the way, would be this one. So exterior plus interior always needs to add up to 180. But anyway, just focus on the exterior angles. For any regular shape, the exterior angle of any regular polygon is 360 degrees, a full circle, divided by the number of sides. Think about running a lap around this pentagon. To do one full lap, you'd turn for a full 360, and you would have done that by going around 5 equally sized corners. So the size of just one of the outside corners, in other words, the size of one of the exterior angles, is the full 360 divided by how many corners you've run around, which should be 5 in the case of a pentagon. So for the pentagon, each exterior angle is 360 divided by 5, which gives us 72 degrees. So I'm going to just label these on 72 degrees each next. Next, we need to look at this parallelogram. So if I just focus on this angle here and this angle in the corner of it, which I'm just going to mark in red, then these here, because the top and the bottom of a parallelogram are parallel, hence the name, this angle plus that one are called co-interior angles. And co-interior angles always add up to 180 degrees. And so if that's 117, this one here will be 180 minus 117. So if I do 180 subtract 117, that tells me that this angle here has to be 63 degrees. So let's add this in and explain it with the working. So again, showing all your working, don't just label 63 degrees, explain how you got it at 63 degrees. We did this, and then mention as well, use the fact that co-interior angles add up to 180 degrees. And I forgot my damn bracket, silly me. So next up, so now we can actually think about this angle called X. So just adding on the X in blue, you can see here the 72 degrees exterior angle, this 63 degree angle within the parallelogram, and angle X all lie on this straight line. So we need to know that angles on a straight line add up to 180 degrees. So all these three added adds up to 180 degrees, and then quote the angle factor you're using. It's because angles on a straight line add up to 180 degrees. I'm not doing very well with my brackets today, am I? So close that one off again. And then from this we can then rearrange this easily by just doing 180 take away 72 and take away 63. So if we do that, 180 take 72 take 63 will give us x, which therefore is 45 degrees. So the final thing is therefore x has to be 45 degrees. Question 9, we have to enlarge triangle A by scale factor 2.5 with centre 0, 1. So 0, 1 is actually being given for us here. It's been crossed. There's several different ways of performing enlargements. I'm just going to show one here because this is a relatively simple one, but it's a few pointers. We can draw lines going from the centre of enlargement that just scrape each and every corner of the shape. Because the triangle, there's only 3 corners, so do a straight line from the centre, touching that corner and extending on, same with that corner and same with the bottom one. And what this tells us is that the corners of the new enlarged shape will also be exactly on these red lines, just as the original shape was. Just returning to the scale factor for a moment, it's scale factor 2.5. So what does that mean? Well, you can think of it in one of 2 different ways, really. So each side becomes 2.5 times as long, so it gets 2.5 times longer. And another way of thinking about it is each point becomes 2.5 times further away from the centre of enlargement than what it is originally. But just using this idea of these sides getting 2.5 times longer. If I look at this top edge here, from there to there, that's 2 squares long. 2 times 2.5 is 5, so the new enlarged shape, this top edge needs to be 5 squares along. So just check along here until we get to a distance from this red to that red, which has 5 squares. That's 2.5 squares, no. 3 squares, no. 3.5, 4 squares. This one's a half, 1, 2, 3, 4. But this one here you can see is 1, 2, 3, 4, 5 squares. So this top edge here has to go, therefore, along this bit here. So we can add this one in. And once you get one side, you can just build the others around it. So of course, will just be a vertical line going from here down to the very bottom, then finally from the bottom straight up to complete the triangle like so. And just to add a bit of colour, why not just do this? I'm not saying colouring in your exam, but just make it clearer. That's where your final enlarged triangle needs to be to secure you the marks. Question 10, some solving equations and simplifying. So this first one, solve 9 plus x over 7 equals 11 minus x. Decisions, decisions, decisions. The first thing I'd suggest to do would be to just get rid of this fraction here, get rid of dividing by 7 by multiplying both sides of this equation by 7. So 9 plus x divided by 7 times 7 just gives us 9 plus x. On the other side, need to multiply everything by 7. So 11 times 7 is 77. Minus 1x times 7 is minus 7x's. We've got x's on both sides of the equation. We're always going to try and eliminate the smallest value of x's from one side. So what's smaller, 1x or minus 7x's? Well, minus 7 is a smaller amount. So I'm going to eliminate the minus 7x by adding on 7x's to both sides. After doing that, the left becomes 9 plus 8x's. Over here, no x's are left because they've been cancelled off. I'll just have 77. I want the x's to be on their own, so I want that 9 to disappear. Hence, we're going to take away 9 from both sides. So 8x is going to be 77 take away 9, which is going to give us, whoops, what am I talking about? It's going to give us 68. I think I need a better night's sleep tonight. What am I thinking? And finally, to go from 8x down to just 1x, final step, divide both sides of this by 8. And so x equals 68 over 8, and let's not be too blasé, let's use a calculator for this one. 68 over 8 is 17 over 2, or if you want to, you can give it as 8.5. Either or doesn't matter. So either 8.5 or 17.2. I think I'll go for the decimal today. Why not? And part B, simplify this. Before simplifying it, I'm going to do the opposite in a way. I'm going to write it out in the long way. So what this actually means here is 4 lots of that bracket cubed. It actually means 4 lots of this bracket written out 3 times. So that means 4 lots y plus 3 once, y plus 3 twice, y plus 3 a third time, and y plus 3 squared just means y plus 3 multiplied by y plus 3. We can then see what cancellations we can do much easier. So this bracket will cancel with that one, this one will cancel with that one, so we have no denominator left. We're just left with 4 lots of y plus 3, and therefore that's our final answer. No need to expand it, you just give yourself more work to do. That's absolutely fine to leave it like this. Question 11, we have a tree diagram. So the probability tree diagram shows the probabilities that Bisma will be late for work on 2 days next week. Calculate probability that Bisma will be late on exactly one of the 2 days. Well, that means they could be late on Monday, but then not Tuesday. Or they could be on time on Monday, not late Monday, but then late on Tuesday. So there's 2 ways that could be done. So first of all, they could be late and then not late, or they could be not late and then late. So what we need to work out here is this. Probability late exactly once is probability of being late and then not late, this yellow route, or probability of being late first and then not late. Sorry, and then late. So you might wonder why I've got and then in red and or in blue. It's because of probability. If it's one thing and then the other with a tree diagram, what we need to do is multiply the probabilities as we go along the branches. So late and then not late, we cross 0.07 and 0.98. So we have to multiply these together. So late 0.07 and then not late is 0.98. So that's how you work out the probability of going down the yellow route. And then or, in this case, means we add also to that the probability of not being late, 0.93, multiplied by the probability of then being late, 0.11. So the next bit is 0.93 multiplied by 0.11. It's just a case of adding these together, and that's going to be our final probability. So get the calculator ready and up. So we're going to have here the following. So 0.07 times 0.98 added to 0.93 multiplied by 0.11. Press equals and it comes to this. So what we could do is give this in terms of a decimal or a fraction. I'm going to go for a decimal and say it's 0.1709. And that's all we need to do. Question 12 is about stem and leaf diagram. So this is a stem and leaf diagram here, and it shows information about the heights in centimetres of 23 sunflowers. So we have a key, which every good stem and leaf diagram has to have. So 17 line 3 represents 173 centimetres. Then what we need to do is to draw a box plot for this information on this grid here. The key thing about a box plot is there's going to be 5 vertical lines that build it, and the 5 vertical lines relate to 5 different key points in any distribution of data, and the 5 points are as follows. First of all is the smallest value, then the lower quartile, median and upper quartile, then finally the biggest value. So the smallest and biggest are the easiest to start with, so let's do those. So the smallest value is the first value here, which is 17 line 3, which this says nicely for us, by chance, that's 173 centimetres. So the smallest sunflower is 173. At the other end of the scale, the highest, tallest one, will be 21 dash or line 9, this one here, and that's going to represent 219 centimetres. Now, The lower quartile, median and upper quartile take a bit more thought. So the median is what I'm going to start with first. The median is the middle one. So if we've got 23 sunflowers, then there'd be the smallest 11 here, the highest 11 on the other side, then the median will be the one in the middle. So the median is actually going to be the 12th one. Smallest 11, middle one's a 12th, then the biggest 11. So what we can do now is count along until we get to the 12th value. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So our median is going to be 197. Next, the quartiles. So what we do for the quartiles is we can essentially forget about the median and just look at the 11 values either side. So the lower quartile, the 11 values before the median, we need to find the middle of these 11. So we've got 11 values. You could imagine these as being split into 5 smallest, 5 which are the biggest of these 11, and the middle one will therefore be the lower quartile. So the lower quartile in this case is going to be the 6th value. So 1, 2, 3, 4, 5, 6, 1, 8, line 8. So the lower quartile is 188. In a similar way, you can work out the upper quartile just looking at the higher 11 on the higher side of the median and split these so that we can find the middle one. So 11 values on the higher side of the median. We can split these into the 5 smaller ones of the 11, the 5 higher ones of the 11, and in between the 6th one of these will be the upper quartile. So the upper quartile is 6th out of these 11. So we've got the median, which is 12th, then 6 on after that, the upper quartile will be the 18th. In other words, it's going to be the 6th after the median. So I'll just add this in as well. So it's the 6th one after the median. So start at the median. 1, 2, 3, 4, 5, 6. We can see, therefore, that the upper quartile must be 209 centimetres. Now we know these 5 points, we can now add in the 5 vertical lines on this diagram here. So 173, we need to do a line at 173, 188, 197, 209 here, and then 219 almost at the end. So then we're going to have something like this. And then what we do is, with the 3 lines in the middle, we need to do a bar along the top and the bottom, which makes the box, as in the box plot, like so. Then finally, from the box to each of these end bits, the minimum and the maximum, we do little whiskers from the box to here, and from this end of the box to the final one, like so. And that's our box plot completed. Question 13, we've got 2 liquids, A and B, that are mixed together in the ratio 2 to 13 by volume, not by mass, but by volume, to make liquid C. So liquid A is 2 parts to every 13 parts of liquid B. We're then told the corresponding densities of A and B. So A has a density of 1.21 grams per cubic centimetre, and liquid B has a density of 1.02 grams per cubic centimetre. So because we're talking about densities and volumes, it's going to be related to density, mass and volume. So density equals mass divided by volume, hence this formula triangle here we can use. So let's just think about making this liquid C. So liquid C could be made by mixing 2 centimetres cubed of liquid A plus 13 cubic centimetres of liquid B. So let's just consider that. What we can now do is to work out the total mass of 15 cubic centimetres of C by working out the mass of this much of A added to the mass of this much of liquid B. And to work out the mass, if I cover this up like so, the mass is density multiplied by volume. So considering liquid A first, the mass of 2 cubic centimetres of A would be the density of liquid A multiplied by the volume of liquid A. So that's going to be 1.21 multiplied by the 2 cubic centimetres we need, which is 2.42 grams. Similarly, for liquid B, the mass of 13 cubic centimetres of B is a density of B multiplied by the volume of B, which is 1.02 multiplied by the 13 cubic centimetres we need, which is 13.26. If we add these two together, we can then find the mass of 15 cubic centimetres of liquid C. So 15 cubic centimetres of C is this 2.42 plus 13.26, which is 15.68 grams. So what we could do now, if we wanted to, is to work out the density of C. So therefore, the density of C, so to work out density, take the hand, cover up, it's going to be the mass of C, which we worked out was 15.68, divided by the volume of it. Well, we worked out the volume we'd make here was 15 cubic centimetres. So 15.68 divided by 15, what does that give us? Let's see. Divide by 15, we're going to get 1.0453 recurring. It is the 3 which is recurring? Yep. It's that many grams per cubic centimetre. So what's this liquid C doing? Well, it's actually going to be filling a cylindrical container. And this cylindrical container has radius 3 centimetres and height 25 centimetres. So let's picture this cylindrical container next, which is like this. So we need to work out the volume of this cylinder. So you need to recall how to calculate the volume of a cylinder. It's the area of one of the circular ends of it multiplied by the length, or in this case, the height. So area of a circular end multiplied by the length. So the circular end, obviously, is going to be this here, and the radius is 3 because it told us. So how do we work out the area of a circle? It's pi r squared. So that's going to be pi times the radius, which is 3 squared, multiplied by the length, or the height, which is 25. So let's do this on a calculator. Pi times 3 squared times 25. Pi times 3 squared times 25. 225 pi. You can leave it in terms of pi if you want to. That's absolutely fine for now. 225 pi. The final step is we want to work out the mass of the liquid in this container. So to calculate the mass, we use this formula relation again. So the mass in the container is the density of the liquid filling the container multiplied by the volume of this container. So therefore, mass of liquid in the cylinder is going to be the density of the liquid filling it, which we've got here, 1.0453. So I suppose if we want to, I can colour code that. I do like a bit of colour coding, I don't know if you've noticed. 1.0453 multiplied by the volume of this cylinder, which again, of course, we worked out from before, 225 pi. Now we've got 225 pi stored from our answer previously, as you can see here. So all we need to do here is to multiply that by the density, which is 1.0453 recurring. So I'll just bang on a few extra 3s so I don't round too soon. Press equals to get this in terms of pi. Do I want my answer in terms of pi? Let's read the question carefully. We need our answer to 3 significant figures. So no, we need a decimal answer. So press S arrow D. 738, you might be tempted to say, but no, because next to the 8 is a 9. So the 738 is forced to round up to 739. So the total mass is 739 grams. Quite a nasty question that I thought, but there you have it. Some questions on higher tier are quite nasty, sadly. Question 14 is in my opinion, quite a nasty question, really. It's a ratio question in name, but we're actually going to see it's slightly different than most ratio questions. So what's it talking about? It's a group of people going to a restaurant, and each person chooses one starter, and then they choose a main course after. So you can have soup or prawns to start, then the main course can be lasagna or curry. We're then told the number of people that choose soup to the number that choose prawns is in the ratio of 2 to 3, and of those who choose soup, the number that choose lasagna to the number who choose curry is 5 to 3, and then also, of those that choose prawns, the number of people that choose lasagna to the number of people that choose curry is 1 to 5. What fraction choose curry? And we have to show how we get our answer. So even though this is a ratio question in terms of how it looks, you can actually think of this in terms of a tree diagram. So what am I getting at here? Well, the main thing I'm trying to say is that it's a tree diagram question in disguise. It doesn't mention anything about probability, and probability is where you consider tree diagrams to be. However, this one here, you can think of it as a story. So the first branch is picking the starter, the next step and the next branches are the main course. So if you think about it this way, so starter could be soup or prawns, and then for each starter, whether it be soup or prawns that's picked, the main course could be lasagna or curry. So it's like a tree diagram similar to this. We can now add in the information given in the ratios as well. So let's have a look at this first of all. So the number of people that choose soup to the number that choose prawns is 2 to 3. So this bit here, 2 parts for soup, 3 parts for prawns is 5 parts in total. So those that choose soup, that's 2 out of every 5 people. That's 5 parts in total. I'll just make a note of that. So those picking soup is 2 out of every 5. And therefore those picking the prawns is every third person out of 5. Then the other ones that choose soup, so choosing soup's chosen, the number that choose lasagna to the number that choose curry is then in the ratio 5 to 3. So 5 parts and 3 parts. This one's a total of 8 parts. So lasagna is 5 parts out of 8. And those that choose curry is the other 3/8 of the people. And then of the people that choose prawns, we're told those that choose lasagna to the number that choose curry is in the ratio 1 to 5. And 1 part plus 5 parts is a total of 6 parts. And so of the people that choose prawns, down at this branch, the lasagna choosers are 1 out of every 6 people. So that's 1/6 for lasagna, and the other 5 out of 6 choose curry. We can now begin to actually answer the question which we need to. So what fraction of the people choose curry? Well, there's 2 ways they could choose curry. So one thing is, the person could choose soup first, so go along this branch, then after soup, they then choose curry. So they can choose soup and then choose curry. The other way this could be done is if they were to pick prawns, then after picking prawns, then choose curry. So there's 2 main branches to consider. So for here, we need to think of it in this way. So the fraction of people that choose curry, we've got here 3/8 of the 2/5 of the people that choose soup, this top yellow branch, but then also 5/6 of the 3/5 of the people who choose prawns. So it's 3/8 of the 2/5 of people, and also, so plus the people that choose prawns. So 3/8 of 2/5. To find a fraction of another fraction, we simply multiply the fractions together. So that's 3/8 of 2/5. That accounts for those that choose the soup and then go for curry. Then we're going to add on to this 5/6 of 3/5, which is 5/6 multiplied by 3/5. So we now just trust to our calculator to do this final step, and we're then finally done in a fairly awkward question, I think. So 3/8 times 2/5, let's just do this. Move the calculator to one side. move that there. So 3/8 multiplied by 2/5, that's the first step. And then we're going to add on to that 5/6 of, so then multiply 3/5. Press equals, and our answer is 13 out of 20. So in other words, about 65%, well, exactly 65% of the people are choosing curry. So curry's popular choice. Final answer, 13 over 20. 15. Prove algebraically that the sum of the squares of any two consecutive even numbers is always a multiple of 4. So before we get started with this, I'm just going to put a thought bubble up here and just think through how we're going to tackle this. Well, the first thing is it's algebraic. So this is going to freak some people out to begin with, because it always upsets me how many people are a bit worried and scared of algebra. But algebraically, how can we write down an even number? Well, any even number is always going to be 2 multiplied by something. Any even number is just 2 multiplied by any whole number. Let's call it n. So let's call our first even number 2 times n. So the first even number we have, let's call that 2n. Consecutive means next to each other. So the next even number is one consecutive, the next one after the first. So if the first one is 2n, and the second even number, we can say, is going to be 2 bigger than the first one, because even numbers go up in 2s. For example, 8 is 2 bigger than 6, quite obviously. So if we call the first one 2n, the second one we can call 2n plus 2. So what we need to now do, now we've set up a question, we've got the 2 consecutive even numbers, 2n and 2n plus 2. We have to prove now that the sum of the squares of these 2 consecutive even numbers is always a multiple of 4. So what is a multiple of 4? Well, a multiple of 4 is just 4 multiplied by something. So our target is to prove that the sum of these squares is a multiple of 4, which is 4 times something. That's how you write a multiple of 4. It's 4 times whatever, where this question mark is a whole number. So let's do this next. So the sum of the squares, so 2n squared, because it asks for the squares, so 2n squared plus the next one, 2n plus 2 squared, and the sum because we're adding together. So we need to manipulate this algebraically to arrive at something which we can prove is a multiple of 4. So first of all, the easy one is 2n squared. So 2n squared, if we square the 2, we get 4, because 2 squared is 4, and n squared is just 4n squared. So we've done the first bit, so we can say that therefore this thing here is 4n squared, and then 2n plus 2 all squared, we can expand out by either using FOIL, or as I personally prefer, using the grid method. So 2n plus 2 all squared means 2n plus 2 multiplied by 2n plus 2, which we can set out like this. So 2n times 2n, that's going to give us 4n squared. 2n multiplied by 2 is 4n. 2n multiplied by this 2 is also 4n. And finally, 2 multiplied by 2, 2 squared, is 4. So if we then simplify this down, we have 4n squared. 4n plus another 4n is 8n. And finally, we've got that plus 4 there on its own. So expanding all this out, we've got here that it becomes 4n squared plus 8n plus 4. So we now have that 2n all squared plus 2n plus 2 all squared equals 4n squared plus 4n squared plus 8n plus 4. Now, The next thing is to simplify all this. So 4n squared plus 4n squared is 8n squared, 8n and then plus 4. But then if we go back to what was in this thought bubble here, we need to prove that this is a multiple of 4. So we need to factorise out a 4 from all of this. Can we do? Yes, we can, because 8, 8 and 4 are all in the 4 times table. So then our final step is just factorise out a 4 from all of this. So it's equals 4. Don't try and factorise out anything else. We're only trying to prove it's a multiple of 4, so just factorise out the 4. So to get 8n squared, we times the 4 by the 2 to get the 8. Then n squared means we need n squared here. Similarly, to get 8n, we times the 4 by 2 to get the 8. Then to get the n, we include an n here. We've got 4. We need 4, so we multiply the 4 by 1, because 4 times 1 gives us that 4 we need. Then we just can conclude, if we want to, by saying which is a multiple of 4. And that's all we need to do to impress the examiner and to get ourselves full marks. But the overall end expression should be something like this. That's the most important thing. Then you can say, if you want to really impress, that's a multiple of 4, because a 4 is factored out on the outside. Question 16, we're told that y is inversely proportional to the square of x. We're also told that when y is 8, x is 2.5. Find the negative value of x when y is 8 over 9. So importantly, we're talking inverse proportion. And the symbol for proportionality is this fish symbol, like so. It's not actually called a fish, but it looks like a fish. So y is inversely proportional. Inversely proportional means 1 over what it's inversely proportional to. So because it's inversely proportional to the square of x, that means y is proportional to 1 over x squared. The square of x means x squared. It's not the square root of x. This means x squared. We now need to replace the fish-looking symbol with an equals. So what we do here is we just replace the fish with an equals, and then we do k, where k is some constant to be found, multiplied by 1 over x squared. So we can write it as just k over x squared, because k times 1 over x squared is written simpler like this. We can then substitute in the values we know. So what we know here is when y is 8, x is 2.5. So we can substitute this in. So when y is 8, we know that x is 2.5. So x squared is 2.5 squared, just subbing in that x is 2.5. So now what we can do is we can rearrange this equation to work out the value of k by simply multiplying both sides of this by 2.5 squared. And when we do that, we'll work out what k is. So therefore, k is going to be 8 multiplied by 2.5 squared. And at this point, we may as well use our calculators to see what this comes out to be. So 8 multiplied by 2.5 squared gives us a value of 50 exactly. So we can call this equal to 50. So therefore, the equation is that y equals 50 divided by x squared. And that's the equation we can work with. So we're now told to find the negative value of x when y is 8 over 9. So now we just substitute in that y is 8 over 9. So we can solve and rearrange what x will have to be. So 8 over 9 equals 50 over x squared. Now there's a few different ways of solving an equation like this, where it's one fraction equals another. My favoured way is to just cross multiply. So 8 times x squared must be equal to 9 times 50. So we can write this down. So 8 times x squared is 8x squared. 9 multiplied by 50 is 450. If we now divide by 8 to find what x squared is on its own, divide both sides by 8 to make x squared the subject, we then see that x squared equals 450 divided by 8. Let's see what this comes out to be. 225 over 4, which is 56.25. You can leave it as a fraction if you want to. Doesn't really make any difference. Now to go from x squared to x, we simply square root both sides. However, if x squared is 56.25, we need to remember that x could be either the positive or negative square root of 56.25. And so if we just square root this on a calculator, a bit messy that. So square root this answer, we get 15 over 2, which is 7.5. So x is plus or minus 7.5. But this question is asking for the negative value, and so what we do is just simply ignore the positive option and go for the negative. So x must equal minus 7.5, because we want the negative answer only. And that's our final answer for that one. So we can now go on to the next one, question 17. Question 17, we have a graph of y equals x squared minus 3 shown on this grid here, opposite. And we're asked to use the graph to find estimates for the solutions to the equation x squared minus 2x minus 2 equals 0. So if I just highlight in x squared minus 3, which is this red line, if I go over this in a deeper, clearer red, like so, we can see here that this x squared minus 3 equation, well, expression, looks totally different to x squared minus 2x minus 2. So we're talking about two separate things here. What we need to do is to make this one match up to that one so we can compare like for like. So what we need to do here is to make this one match up to x squared minus 3. And at the minute, it doesn't look like it. So what can we do to both sides of this equation here? So just getting it writ here slightly bigger. What we could do as a first step would be to take away 1 from both sides. So we go from minus 2 to this minus 3. So then we'd have that x squared minus 2x minus 3 equals minus 1. Over here, though, we don't have any minus 2x's. We have no x's at all. So we need to get rid of these minus 2x's by adding on 2x's to both sides. Then what we'd have is that x squared minus 3 equals 2x minus 1. So on the left, we've got here x squared minus 3. Then on the right, we've got 2x minus 1. The graph of x squared minus 3 has been plotted here. So what we could do is plot the graph of 2x minus 1. And where the red graph meets the graph of 2x minus 1, that will relate to the solutions of the equation here, which we want to solve. Because all this is at the bottom is a rearrangement of this, what we're trying to solve. So this here is one and the same as this, just written a different way. So as long as we can draw straight line graphs okay, we need to plot on y equals 2x minus 1. This will have a gradient of 2, because the number in front of the x is a 2, and it'll cross the y-axis at minus 1. So with a bit of care, you should draw this line here looking something like this in blue. Here's one I did earlier. Then we just need to see where they cross over. So clearly, the red and the blue cross here and there, and these 2 points relate to the solutions of this equation we need to solve. So we just read from this graph down, and from this point reading up, like so, and you should find that x is either approximately 2.7 or x is approximately minus 0.7. And so finally what we can do is say that x equals minus 0.7 or 2.7. So you need to be within plus or minus 0.1 of these answers to be close enough and accurate enough to get the marks. So your answer should be very close to minus 0.7 or 2.7, but you must show how you get your answers, ideally by using this graph. You can't just use your calculator to arrive at these. You need to show, using this method, why the solutions are these. Question 18 is something of a beast. So we've got a triangle ABC as shown, and then all the sides of the bigger outer one, ABC, are labelled. So no, BC is 6.1, AB is 3.4, and A to C is 6.2. And we're told that D is somewhere on the line from B to C, so that it makes the angle DAC, this one here, 2/5 the size of angle BCA, which is this one here. So obviously to work out DAC, it seems like we might need to work out BCA. So that's going to be our starting point. So BCA is this angle here in the corner as we go from B to C to A. So I'm going to label this in yellow. And what we need to remember is If we look at the outer triangle ABC, whether it be right-angled or not, if we know all the different lengths of each and every side of a triangle, we can use the cosine rule to find out any angle we want. And so to find out the size of angle BCA, we use the cosine rule, which is as follows. If I just get this line from A to D to disappear, so just focusing on the outer triangle, the cosine rule we can apply as A squared, which is the side opposite triangle we're trying to find, equals B squared plus C squared minus 2 times B times C times cos of big A. What we need to do is label the angle you're trying to find as big A, so I'm going to call this one big A, and the side opposite to it little a. Then in any order, the other two sides are B and C. So this is how I've picked it. Big A, little a, that has to be done. Now I've just picked that little b is 6.1 and little c is 6.2. If you had C up here and B down there, that would work too. Now what we need to do is just substitute in A squared as being 3.4 squared, B squared being 6.1 squared, and so on. So substituting in A, B, and C, this formula here becomes like this below. 3.4 squared equals 6.1 squared plus 6.2 squared minus 2 multiply 6.1 multiply 6.2 multiply cosine of A. We can now neaten this up. So for example, 3.4 squared, we can just work that out with a calculator. So for example, 3.4 squared, we can replace that with 11.56. And similarly for all these different values here. So the next line, just neating it up slightly, we have that 11.56 equals 37.21 plus 38.44 minus 75.64 lots of cosine of big A. Grouping these together, 37.21 and 38.44, we can make this slightly simpler again. So 37.21 plus 38.44 gives us 75.65. So another line of just neating it up slightly. We have 11.56 equals 75.65 minus 75.64 cosine A. We need to make cosine A the subject, so we need to get this 75.65 disappeared. So we can subtract this from both sides like so. If we take 75.65 from both sides, then the 11.56 is going to become, let's just see, we get here, but it'll be minus 64.09. So the next step is that minus 64.09 equals minus 75.64 cosine A. We can now divide both sides of this equation by minus 75.64 to make the cosine of A on its own. So minus 64.09 divided by the, what was it now, minus 75.64 tells us that the cosine of A must be 0.847303 and so on and so on. So dividing both sides by 75.64 gives us this. Cosine of A is about 0.8473. To work out what the angle A is, we do inverse cos. So we do cos minus 1 of this value here, work out what A is. So shift cos minus 1 of the answer, press equals, we get 32.080. So therefore, A is about 32.0804. So we can take off the letter big A, little b, little c, and replace big A with the size of what the actual angle is. So if I just label in here, this is 32.0804, we can now return to working out and thinking about what angle DAC is going to be. So if I put this line back in here, and we now slowly forget about the outer triangle ABD, so all this can go away, so we just focus on this triangle ADC in the middle, we can think about what angle DAC is. We just work out 2/5 of this angle here. So if we do that, take it and times by 2/5, basically working out 40% of it, we get that this angle here is about 12.832. So we can label this in, 12.832, and a bit more accuracy if needed. Never round your answer too soon. If in doubt, give more significant figures as needed. Only round off at the very end of an answer. Don't round too much too soon. Like I say, we can now zone in on triangle ADC and wave goodbye to the outer triangle. And what we're going to do in a second is use the sine rule. Because you know these two angles, we can work out angle D. So I'll add this in a second. And then we can do 6.2 as the opposite side to this sine. So 6.2 divided by sine of this angle. We can use this side DC and sine of 12.83218. So just to explain that a bit better, the cosine rule we've used. To find length DC, we're going to now use this sine rule. So the size of any side divided by the sine of the angle opposite to it will be equal to the size of any other side divided by the sine of the angle opposite to that other one. So we can label in the angles and the sides appropriately. So opposite to big D, I'm going to call that little d. DC I'm going to call little a, and that's our big A. So the two pairs of sides and angles I'm going to use are DC and angle A, and also big D and 6.2. To work out this angle here, because we know that angles in a triangle add up to 180, we can just do 180, take away this angle, take away that one, and we see that this one here is 135.087. So, using the sine rule with these two pairings, we've got DC, this one, divided by the sine of 12.8328 opposite to it, will be equal to 6.2 divided by sine of the angle opposite to that one, this pair here. So here, this can be rearranged. We can get DC on its own by multiplying both sides by sine of 12.83. And if we do that, we've essentially got our answer because we're just working out what DC is. So DC is going to be 6.2 over that, multiplied by sine of 12.83. So as our final step, we've got 6.2 over sine 135.08 multiplied by sine of 12.83, and so on and so on. And you should get an answer that rounds to 1.95 to 3 significant figures. We need it to 3 significant figures. So this is 1.95 centimeters, like so, and that's our final answer for question 18. Quite a hard question, that, not the most straightforward one. Question 19, we have a graph showing information about part of a cyclist's journey. And as you can see, this is not a straight line graph. It's distance on the y-axis and time on the horizontal axis. We need to work out an estimate of the speed in meters per second of the cyclist at the time 6 seconds. So distance divided by time equals speed. Distance travelled divided by the time taken to make that distance is speed. And of course, we can't work out this as a constant gradient because this isn't a straight line. So what we need to do is to find an estimate of the gradient instantaneously at the time 6 seconds, which isn't a straight line. And what we do here is we use a tangent to estimate the speed instantaneously at any one point. So the estimate comes from using a tangent. So speed at a certain time of motion is a gradient of a distance time graph at that point. To find the gradient, we draw a tangent in at the point t equals 6. So if we just label on t equals 6 here, which is going to cross at that point, labelled with a dot, a tangent at a certain point is a straight line that just scrapes the curve at that point. It doesn't cut it here, doesn't cut it below, it just scrapes along the edge. And at GCSE at least, it's not an exact science. So my tangent is something like this in green. As you can see, that green line just touches that red and doesn't cut the curve. If you're cutting the curve down here or up there, you've not done your tangent correctly. Once you've got your tangent, what we can now do is just pick any 2 points on the tangent to work out the gradient. And between those 2 points, the gradient is, of course, the change in y divided by the change in x. Or in our case, the change in distance divided by the change in time. So my 2 points, I'm going to label on with a red cross, like so. This one and that one. So I can work out the distance from here to there going across. That's between 2 and 4 seconds, so that's 3. This one here is 8. So the change in x along here, I can work out. That's going to be 5. And vertically, I'm starting from 0 and going all the way up to this point here, which is 17. That's 15, 16, 17. So the vertical change is 17, the horizontal change is 5. So write that down on your exam paper to show to the examiner you know what you're doing. So now all we need to do is to compute that. So it's going to be 17 over 5. Use a calculator if you want to. 17 divided by 5. We get here 3.4. And that's an estimate of the speed. So 3.4 meters per second, or ms minus 1. In fact, I'll keep it as meters per second. That's more of an A-level notation. So 3.4 meters per second. Now, your answer might not be exactly 3.4 meters per second, depending on how you drew your tangent. You need your answer to be between 3.1 and 3.7 to be close enough to get full marks. If you're lower than 3.1 or higher than 3.7, you've probably not drawn your tangent quite accurately enough. Question 20, we have the first 5 terms of a sequence. Minus 1, 0, 3, 8, and 15. We need to find an expression in terms of n for the nth term of a sequence. Now, importantly, this isn't a basic nth term one. This isn't a linear sequence. The sort of trick is, if it's question 20, it's not going to be that straightforward. So this is actually a quadratic sequence. I'm going to explain how you know that it is a quadratic sequence. It's when the gaps in between the terms are increasing, but the gaps of those gaps are constant. So between minus 1 and 0 is a gap of 1. Between 0 and 3 is a gap of 3. Between 3 and 8 is a gap of 5. Between 8 and 15 is a gap of 7. But then if we have a look at the gap between these gaps, between 1 and 3 is a gap of 2. 3 and 5 is a gap of 2. 5 and 7 is a gap of 2. So when the gaps of the gaps are the same, we know we're talking about a quadratic sequence. When talking about quadratic sequences, I think it's useful to remember the quadratic formula, ax squared plus bx plus c. We can think of a quadratic sequence in very much the same way. So what I'm going to ask us to think about here is thinking about the nth term as an squared plus bn plus c, essentially replacing the x's with n's, like so. So like I'm saying, all quadratic sequences can be expressed as an squared plus bn plus c, where a, b, and c are just values that you need to find. And so I'm likening this to the quadratic formula, ax squared plus bx plus c, just about that equals 0 bit. If you remember that bit, it's exactly one and the same thing, pretty much. As you can see, pretty much the same, just with the x's switched in place for n's. So with that in mind, all we need to do is actually think about the first 3 terms. So the first term is minus 1, the second term is 0, the third term is 3. So all we need to focus in on is just, after doing a table of the terms, term number, and the term values, we just focus on the first 3 values, minus 1, 0, and 3. So when n is 1, we can just substitute in n is 1 into an squared plus bn plus c. So when n is 1, we've got that minus 1 equals a times by 1 squared, because it's your first term. 1 squared is just 1. A times 1 squared is just a, plus b times 1, which is just b, plus c. For the second term, when n is 2, that's 0. So the next line is 0 equals 4a plus 2b plus c. Because when you substitute in that n is 2, an squared becomes a times 2 squared, and 2 squared is 4. That's where we get the 4a from. Then plus b times 2, 2b, and always just that plus c. The next one for the third term is 3, so the final line is 3 equals 9a plus 3b plus c. It's 9a because the an squared is a times 3 squared, because n is 3, and 3 squared is 9. B times 3, hence for 3b, and always that plus c. Now, if you can remember this format, the general rule for finding the nth term, you can always follow the same process. These numbers here, 1, 2 and 3, are your first three terms, but this a, b, c, 4a, 2b, c, 9a, 3b, c are always the same. It's always the same structure for your first three terms. Now we've got those, we can now work on these as two sets of simultaneous equations to work out what a, b and c are. So if we look at the top equation and the middle, if we do the middle equation, take away the top one, we can eliminate the c. So 0 minus minus 1 is 1. 4a take away a is 3a. 2b take away this b leaves us with 1b. c take away c cancels. These bottom two, we can now do the bottom equation, take away the top one. So 3 take away 0 gives us 3. 9a take away 4a is 5a. 3b take away 2b leaves us with just 1b. And again, c take away c cancels. We can now go again to cancel out the b's. So again, if I do the bottom one take away the top, just to avoid any negative numbers, 3 take away 1 is 2. 5a take away 3a is 2a, and the b's cancel. So 2 equals 2a, so therefore a equals 1. So now we know that a equals 1, we can now begin to substitute this back in and work backwards. So if a is 1, we can pop this back into one of these initial equations here. So if I put a equals 1 into this one, for example, I then get that 1 equals 3a, because a is 1, that's just 3 times 1, plus b. And if we then take away 3 from both sides, we can see that therefore b is going to be 1 take away 3, which is minus 2. So we've got that b is minus 2, and then the final step is we can substitute a and b to work out what c is. So now we know that a is 1 and b is minus 2, we can substitute it into one of these formulas here. So b is minus 2 and a is 1. We can now go back and work out what a is. And once we've got, sorry, what c is rather. Then once we've got a, b and c, we've got it correct. So finally, minus 1 equals a, which is 1, plus b, which is minus 2, plus c, which we don't yet know. So minus 1 equals 1, which is a, plus b, which is minus 2, plus c. So neaten this up, we'll therefore have what c is. So minus 1, 1 plus minus 2 is the same as 1 take away 2, which is minus 1. So minus 1 equals minus 1 plus c. So therefore, well, minus 1 is already equal to minus 1. We don't need anything else, so c has to be 0. So then we've got it. The nth term is therefore as follows. A, n squared, well, a is 1, so it's just simply n squared, and then b is minus 2, so it's n squared minus 2n, and because c is 0, we just leave it like that. So the nth term of this sequence is just n squared minus 2n, and that's all we need to do. Question 21, we're told when a biased coin is thrown 4 times, the probability of getting 4 heads, and this means 4 heads in a row, is 16 over 81. Using this information, we then need to work out the probability of getting 4 tails in a row when this particular same coin is thrown 4 times. So if I just highlight this bit here, the probability of getting 4 heads is 16 over 81. That means getting heads first, and then heads again, and then heads again, and then heads again for a 4th time in a row is 16 over 81. So we can write it out like this. Chance of getting 4 heads in a row, heads first, and I've put in bold red, and then heads second, and then heads third, and then heads fourth. Now, I've done this because in probability, if one event happens and then another immediately after, that will almost always mean we can multiply together these probabilities. And so we can replace the and then with multiplications, and if we let the probability of heads stand for big H, then we can simplify it like this. 4 heads in a row, we're told is 16 over 81 as a chance. That must be H times H times H times H. The chance of getting heads first will be the same as getting heads on the second throw, third throw and fourth throw and so on, because it's still the same biased coin we're talking about. So if we're taking H and multiplying it by itself 4 times, that's obviously H to the power 4. So we can say 16 over 81 equals H to the power 4. At this particular moment, we need to think of how to undo doing something to the power 4. Well, if we wanted to work out what x was, if we had x squared, we'd square root. If it was x cubed, to undo that, we'd do the cube root. And in the same way, to undo to the power 4, we take the 4th root. And so h is going to be the 4th root of 16 over 81. Essentially all I mean is, what value, when it's multiplied by itself 4 times in a row, would give you 16 over 81? So the calculator can do this, which I'm going to show you now. So we just type in shift and then this button here, and then we can change this to whatever root we're talking about. We want the 4th root, so we press little 4, toggle in to the radical symbol, press fraction, 16 over 81, press equals, and we get 2/3. So therefore, the chance of getting heads equals 2/3. So therefore, if the chance of getting heads is 2/3, the probability of tails, because the coin's either going to be heads or tails, that must be the other 1/3 of the times. So the chance of getting tails on one throw will be 1/3. We want to work out the chance of getting 4 tails in a row, so now we can just take this value and multiply this by itself 4 times. So then the probability of tails 4 times is going to be the probability of tails first, and then the probability of tails second, and then tails the 3rd time, and finally, and then tails the 4th time. So 1/3 times 1/3 times 1/3 times 1/3. Try that on a calculator if you want. You should find that it gives you a value of 1 over 81. So therefore, that's our answer. The chance of getting 4 tails in a row on this bias coin is 1 over 81. Question 22. We've got this horrible looking algebraic fraction to simplify. We need to show that this particular fraction simplifies to just ax, where a is an integer. So all of this horrible thing will simplify to something like 2x or 10x, where 2, 10, whatever is this a value we need to find. We're told we need to simplify it, and so what we need to do here, if we can, is to factorize what we can on all of these 4 bits of these 2 fractions. But as you can see here, we've got one fraction divided by another, and if you take it back to numerical fractions, to do one fraction divided by another, we can keep, change, flip. So we can rewrite this like so. Keep the first fraction as it is, change the divide to a multiply, and just flip this last one on its head. So then we've got 4 different bits: numerator, denominator, second numerator, second denominator. Let's have a look at these 4 components and see if we can factorize each and every one step by step. So over here, let's just consider how we can factorize all of these, which will help us to simplify the whole thing in the end. So 7x minus 14. Well, this is actually quite straightforward to simplify, because 7 and 14 are both factors of 7. So we can say this is the same as 7 lots of x minus 2. So we can simplify that one fairly easily. The next one we need to see if we can simplify or factorize is x squared plus 4x minus 12. Well, this one, we need to find, because it's only just 1x squared, we can think of this as finding 2 numbers that multiply together to give minus 12, and when we add them together, gives 4. Now, the 2 numbers that would work here would be positive 6 and negative 2. So we can say this is x plus 6, x minus 2. And so therefore, that one does factorise as well. This one here looks a bit harder, x cubed minus 36x. One thing we should note here is both terms have an x in them at least, so we can factorise out 1x, and then to get x cubed we take this x and multiply by x squared, and then we need this to be minus 36x, so we times this x by minus 36. Now be careful, this is factorised here, but it's not fully factorised, because x squared minus 36, x squared is something squared, and 36 is a square number. One squared thing minus another squared thing is a difference of two squares. So square root of x squared is x, square root 36 is 6. So if you remember your difference of two squares, x squared minus 36 can become x plus 36, x minus 36. And so this bit here, we can just simplify to this. So this whole thing, x cubed minus 36x, if we factorise it twice, becomes this. And the final one here, x minus 6, well, that just doesn't factorise. So we just leave that one exactly as it is, as x minus 6. So if we replace these unfactorised versions with the factorised versions of themselves, we arrive at this. Now, what we can do is cancel and simplify. At this numerator, we've got x minus 2, and the denominator has an x minus 2. So we can do this one and cancel it with that one. Similarly, looking at this fraction, on the numerator and denominator is x minus 6. So we can cancel this one with that one. And also, on this numerator is x plus 6, but because we've got x plus 6 on this denominator, we can also cancel this one with this denominator too. And then you'll see that the only thing that's left is a 7 on the top here, multiplied by an x on the top here, and 7 multiplied by x is simply 7x's. So after all that mess, it just simplifies out very nicely to exactly 7x. So little a ends up being 7. Question 23 and question 24, the last two are very hard in my opinion, but I'll explain them as best I can. So this one is not easy, but anyhow, we've got a diagram showing a sector OACB, which is here, of a circle with centre 0. For point C, this one here, is the midpoint of the arc as it goes all the way from A to B. The diagram also shows a hollow cone with vertex O, so the point of it, the tip is O, and the cone is formed by joining OA and OB. So if you imagine a major slice of a circle being sort of folded up, this one goes to the middle, and you scrunch A and B together, and it forms like a paper cone. So the key insight here is that the curved surface area of this cone is one and the same as one of the surface areas of one side of this sector, because this is curled up and pointed upwards to make this cone. We're then told that the cone has a volume 56.8 cubic centimetres and a height of 3.6 centimetres. We also have some formulae here which are going to help us. We need to calculate the size of angle OAB of sector OACB. So let's just unpick this step by step. So we're told it's got a volume 56.8 and a height 3.6. Now we are given a formula for the volume of the cone, so we can use these two values in just a moment. So if I highlight on the volume in yellow and the height 3.6, that's h. So we're going to use this in a moment. R is the radius of the cone, which isn't the same as the radius of this sector, so just be very careful there. Now angle AOB of this sector is going to be this major angle here, which is going to be reflex, as you can see. So I'm going to highlight this in the blue. We're trying to find this angle here. I'm going to label this angle theta, which is just a Greek letter. I could have called it x if I wanted to. This is just called theta. So using this formula for the volume of the cone, 56.8 equals 1/3 times pi times radius of the cone squared times the height, which we're told is 3.6. So we can try and rearrange this to work out what the radius of the actual cone is going to be. So what I'd suggest we do first is to get rid of this 1/3 by multiplying both sides of this equation by 3. So if we do 56.8 times by 3, we see here that we'll have 170.4. So 170.4 will equal pi times r squared times 3.6. We want to have r squared on its own, so we can divide through by pi and get rid of this 3.6 by dividing by that as well. So we can divide by 3.6 pi on both sides. So if we do that next, just have r squared on its own, take this and divide by 3.6 pi, gives us 15.0666 and so on and so on. So 15.0666 equals r squared. We can now find the radius of this cone by square rooting 15.066. So if we do that now, square root our answer, that gives us 3.88158 and a bit more accuracy after. So therefore, the radius of the cone is 3.88158. So next, we can add this on like so. And we can also add on this diagram that the height is 3.6. So if we just consider this triangle from O to the middle to C, this is a right angled triangle and we know two sides of it. We know the height's 3.6 and the base is 3.88158. So we should be thinking of Pythagoras because we can work out the hypotenuse O to C. So if I just shade this in pink and expand it and give myself some space over here, we can consider Pythagoras' theorem to work out from O to C, which is the same as this length L, which is called the slant height of the cone. So the hypotenuse squared equals that one squared plus that one squared. In other words, L squared equals 3.6 squared plus 3.88158 squared. So if we do this, so that answer I've just got squared added to 3.6 squared, that's what L squared is. So to get L, I can square root that answer, and therefore L, the slant height, is about 5.294 and 0.219 if you really want to. So therefore, L is 5.294 and so on centimetres. So now we know the slant height, we worked out the radius, and we know the height of the cone as well. So L, R and H we can get rid of and replace those with the actual values. The radius of the cone was 3.88158, the slant height we've just worked out, which is 5.294, and the vertical height of the cone is 3.6. Return to what I said earlier, the key insight, that the curved surface area of the cone will be equal to the area of the sector, is what we're going to do next. So just labelling this on now 5.294, and that's the distance from O to B, as you can see. So 5.294, the slant height of the cone, because it goes from O to A or O to C, that's actually the same as the radius of this sector. So I'm going to label on the radius of this one as 5.294. Return to what I just said, we need to remember that the curved surface area of the cone is going to be equal to the area of that sector OACB. So let's just work out the curved surface area. So therefore, curved surface area look at the formula, it's pi multiplied by the radius of the cone, which is 3.88158, and then multiply that by the slant height, which is 5.294. So if we just calculate this, so I've got a figure there, I can store that. I've got the 5.294, so times that by pi and times by 3.88158. I've got the curved surface area is approximately 64.557 and so on. And that's going to be equal to the area of the sector OACB. So to work out the area of the sector, we think of it in terms of a fraction of a full circle. The area of a full circle is obviously pi times radius squared. The radius of this one is 5.294. Of course, though, this isn't a full circle. It's only a fraction of it, and the fraction of a full circle has 360 degrees. Out of a full 360, we only have theta degrees. So the fraction of the circle is theta over 360, this angle out of 360 times pi times 5.294 squared. And that is going to be the area of sector OACB. And like we're saying here, that's the same as the curved surface area of our cone, which we worked out was 64.557. Now all we need to do is rearrange, find what theta is, make theta the subject, and then we've finally got this beast of the question done. So we can rearrange in any order we want to, really. What I'd suggest we might want to do is to multiply both sides by 360. So if I times that bit by 360 and times over here by 360, what I'd have then is theta times pi times 5.294 squared, and that times 360, so times 360, that gives us 23240 and so on. Then need to get rid of the pi and the 5.294 squared. So if you're feeling brave, what we could do is just divide by all of this. Now we can divide by the pi times 5.294 squared on both sides. That'll just leave us with theta. Oops, not 2, what am I talking about? My bad. It's 5.294 squared. And that'll tell us what theta is. So therefore, theta is going to be this value on our calculator, this 23240, and I'm going to divide that by pi times 5.294 squared, close brackets, and we get here 263.954. The answer, we need to give it to 3 significant figures. So 263. However, that 3 is going to round up to a 4 because next to the 3 is a 0.9. So theta to 3 significant figures is 264 degrees. That's the angle we're trying to find. We have done. That's our final answer. In my opinion, that might be the hardest question on the entire paper. Well done if you've understood that one. I apologise if I couldn't make it any better explained. Final question. Question 24. We have a parallelogram OXYZ. From O to X equals A, and from O to Y equals B. We're now told that P is the point on O to X, such that OP to PX is in the ratio 1 to 2. So from here, we can draw some conclusions. Essentially, P divides OX into thirds. So O to P is just 1/3 the way along. So therefore, OP is just 1/3 of the distance from O to X. But O to X is vector A. So 1/3 of OX is the same as 1/3 of vector A. And in the same way, P to X must be 2/3 the way along O to X. So PX is 2/3 of O to X. And O to X, like we said, is A. So 2/3 of OX must be 2/3 of vector A. This one here, talking about from O to Y is split somewhere along it by this point here labelled R. And OR to RY is split in ratio 1 to 3. 1 part and 3 parts is 4 parts in total, so O to R is only 1 part out of 4. So OR is going to be 1/4 the full distance from O to Y. But from O to Y is B, so 1/4 of that is just called 1/4 of B. And in the same way from R to Y, that'll be the other 3/4 from O to Y, so that's going to be 3/4 of B. So we need to work out in its simplest form the ratio ZP to ZR. So how can we go from z to p first of all? Well, let's just consider that now. So zp, let's think about that. Well, to go from z to p, think of it like roadworks. I want to go from z, get to p, using the vectors I know. Well, from z to p, what I could do is I could go from z down to o, then once I'm at o, I could go from o to p. So zp is zo, then from o to p. But there's no vector I know of yet that gets me from z to o, so I need to think about in itself what vector z to o is. I know that from o to p is going to be a third of a. So I can write down OP as a third of a, but from z to o, what I'd have to do, I think, I'd have to go from z down to y, and then from y down to o. So I could go from z, y, and then once I'm at y, I could go from y to o, and then plus OP, and like I said, OP is 1/3 a. I'm now going to give myself a bit more space so I don't overrun into this working here, so if I just draw a slight line down like so to cut this off. So now we need to think about how we can simplify zy plus yo. Well, we know that this shape is a parallelogram, which is useful. A parallelogram, as we know, the opposite sides are of equal length. So from z to y is the same as from o to x. So zy, I can just say, is the same as from o to x. And then yo is the opposite direction from oy. So yo is the same as minus oy. And again, plus 1/3 a. We can now substitute the actual vectors instead. So we know that o to x is a. We know that o to y is b, so ox minus oy is b. So therefore, we know that vector zo can simplify to just simply a minus b. And of course, because you're adding on the op, which is 1/3 a, add on 1/3 of a, and so that simplifies down to b. A plus 1/3 of an a is 4/3 of an a, and then minus this b. So therefore, we've got that z to p is 4/3 a minus b. What we now need to do is to do the same and think about what zr is in terms of vectors. So let's now consider z to r. So if I again section out some space here, let's think how we can go from z to r. We'll start from z, and to get down to r, what I could do first is go from z down to o. Then once I'm at o, I can go from o up to r. Now z to o, luckily we did that earlier, so z to o we established was the same as a minus b, so that saves us a job. So we can just fill this in now. So from z to o, that's vector a minus vector b. And then vector from o to r, well, we've got here from before that from o to r was simply a quarter of b. So we can add on a quarter of b. So a is just obviously a, minus b plus a quarter is the same as minus 3/4 of a b. So therefore the vector zr is a minus 3/4 b. We now need to work out in a simplest ratio zp to zr. We can now use the idea that ratios operate almost exactly the same as fractions. So therefore, let's think of this as zp as a fraction of zr. So zp is 4/3 a minus b, and zr is a minus 3/4 of a b. Now this looks a mess, quite obviously. Fractions mixed into fractions. What could I multiply both top and bottom by to undo this 3 and undo the 4. How can I undo thirds and quarters? Essentially, what's the lowest common multiple of 3 and 4? Well, 12 is in the 3 and 4 times table. So what I could do here is to times both top and bottom by 12. So if I do that, 4 thirds times 12, use your calculator if you want to, that gives us 16. So that becomes 16a, changed to purple for some bizarre reason, apologies. 16a minus b times 12 is minus 12b. And here, a times 12 gives us 12a, and 3/4 times 12, 3/4 of 12 is 9. So minus 3/4 b becomes minus 9b. We can now factorise both the top and the bottom. 16 and 12 are both factors of 4. So the top factorises to 4. 16a means that take the 4 and times by 4a. Then I need to put in minus 3b. At the bottom, 12 and 9 are both can be divided by 3. So we can factorise out a 3 from these. So to get from 3 to 12a, I need to times a 3 by a 4a. And then to get from 3 to minus 9b, I need to multiply by 3b. And hey presto, you see that there's a common factor on the top and the bottom, which we can cancel out. So then we just have that the fraction of zp to zr is 4 to 3. So the ratio of zp to zr we can get by using this fraction. So the final step is just to make it not top to bottom, but read it from left to right. In other words, therefore, the ratio of zp to zr will be 4.3. And we're finally done. For my money, that was one of the hardest GCSE papers Hayati have gone through. I hope you've not struggled too much, and I hope you found some of this video useful. If you have, please do consider subscribing, leave a nice comment, ask me in class if you see me. But sincerely, thank you for tuning in, and I'll be updating as soon as I can do next. Take care of yourselves, be kind to each other, and I hope to see you all soon. From me, it's goodbye for now.